We saw in the previous lesson that our server program cannot communicate with more than one client at a time. In this lesson, I'm going to show you how to create a multi-threaded socket-based server. One way to handle requests from more than one client is to make the server program multi-threaded. A multi-threaded server creates a thread for each communication it accepts from a client. So, you have to use threads because otherwise clients will be queued up waiting for a connection. Okay, first of all, I'm going to create a server socket object that listens on port 9090. Of course, you can select any port from the port range. I'm going to type server socket equals new server socket. And I'm going to use try-catch blocks to handle input-output exceptions. Because I want to accept multiple clients, I'm going to use a while loop as I did before. Is not stopped. Equals false. Inside the while loop, I'm going to print waiting for clients. And what I'm going to do is to call the accept method. Socket client socket equals server socket dot accept and print client is connected. This loop is pretty much the same for most servers implemented in Java. Because in short, what the server does is this. Step 1. Wait for a client request. Step 2. Process client request. And step 3. Repeat from step 1. A single threaded server processes the incoming request in the same thread that accepts the connection. Until now, our server application has processed the incoming request in the main thread inside the while loop. And now, let's find what separates a single threaded server from a multi-threaded server. Rather than processing the incoming request in the same thread, a multi-threaded server passes the connection to another thread that processes the client request. So, once I get the socket object, I have to pass the socket instance to another thread. That way, the thread listening for incoming request spends as much time as possible in the accept call. So I'm going to use a client thread class, let's say client thread equals new client thread and pass the socket object to the client thread constructor. And start the client thread. I've already added the client thread class. This class should extend thread class, or you can implement the runnable interface. Here I choose to extend the thread class because the client thread class will not subclass another class. And I'm gonna override the run method. Also, I'm going to add a constructor that takes as argument a socket. And I'm going to define a socket variable inside the class declaration, and the initial value for this object is null. Also, I define this variable as private because I don't want to access this variable outside the class. And here equals socket. Okay, now I'm gonna add the same code that we've used in the previous lesson. So, the server sends the hello message, and after that it waits for the client input. After it receives a string message from the client, the server prints the message to the console. The last step is to close the connection. Okay, now let's test our server application. Run file. Waiting for client's message has been printed to the console. And now let's connect a client. Okay, I get the hello client message, and now let's try to connect another client. Bingo! The second client has connected to the server and the server waits for our input. The server application that we wrote in the previous lesson creates a single thread that handles a single connection. When the server is waiting for client input, no other client can connect to the server because the server waits for the client input. Now, our server application creates a different thread for each client. So the server application creates a thread for this client and another thread for this client. Actually, we have 3 threads, one thread for each client, and right now the threads are in the running state because they wait for client's input, and the third thread, the main thread that accepts new clients. When a client sends its input, the socket connection is closed and the client thread is terminated. That's all. Thank you for watching.